Okay, now, I labored that point because asymptotes are tricky, right? And there's more to asymptotes that we still haven't learned yet, but this is enough for now. Okay, we'll get some more interesting ones later. Intercepts. How do I find intercepts? If I want an x-intercept, for instance, I would let y equal 0, wouldn't I? Okay, so if I said, okay, y equals 0, so I'm going to get x squared plus 1 on x equals 0. When you're trying to find a y-intercept, right, the denominator doesn't matter, does it? Right? So long as you get 0 on the top, on the numerator, so long as you get 0 up there, I don't care what's on the bottom. You can have 0 over 2, 0 over 5, 0 over minus 3, 0 over a rock melon, you'll still get 0, okay? So therefore, all I'm interested in is, when's that numerator, when's that 0? And the answer is? The answer is it's never equal to 0. There's no value, no real value of x you can throw in there that will make the numerator 0. So, where are the y-intercepts? Sorry, I should have said x-intercepts. Where are the x-intercepts? There aren't any. Okay. Now, to find y-intercepts, I let x equal 0, right? So when I let x equal 0, I can't let x equal 0. So where are the y-intercepts? Answer? There aren't any. Okay. So I have no intercepts. So that's not very helpful. Like I said, you're going to need a lot of different examples to see the useful things here. Okay. So now what do I do here? Okay. I know that I'm going to be constrained between these two. I know I'm never going to touch either of the axes. Okay. So then you have a question. There are a couple of different places that the graph could go. Okay. For instance, I could put the graph up here. That's one option, right? By the way, I'm only going to care about this side because once I get this side, it's an odd function, so I'll know where the other side goes. You content with that? Okay. Now that's one option, and that obeys the asymptotes that I have. Oop, that's a bit naughty. Make sure you have those equations there. Now that's one option, but it's not the only option. It's not the only thing that this graph can do and obey the two asymptotes I've given it. What else could it do? Yeah, Brendan, how would you word it? Yeah, okay, instead of on the left of this oblique asymptote, I could be on the right. It would look like this, I guess, if I wanted to approach both asymptotes, right? Yes?
Wouldn't it have an x-intercept?
Ah, very good. So how do I know which one's which? Well, in order to be this one, I must collide with the x-axis, but we've already determined that we can't do that, right? So therefore, we can rule out this version over here, okay? I'm going to rub it out now. I know it can't go there because it would do something that I know it can't do, namely have an x-intercept. Okay? So therefore my only option is this guy up here. Okay? Now I've got that, and because that's odd, I have this part down here. Okay, please be watchful, just like in logs and that kind of thing, or any other kind of place where you've got an asymptote. Please make sure you don't trap yourself by putting more information on than you should. Just put your pens down and look up at this. I see many students who, for example, see my graph? How it stops kind of here, but my asymptote I've drawn it to over here. So I see students who say, "Ooh, I should just keep going until like the end, right?" But because it gets increasingly more difficult to draw accurately as you get closer and closer, students kind of end up doing like this, and it wiggles, or even worse, it doesn't wiggle, it actually goes away, just gently. Now just look at that, right? The difference is very minor, isn't it? Like it might be a millimeter or two on your page, but this is no longer correct, is it? Right? Why not?
Because it's not approaching me.
It's not approaching anymore, right? So my asymptote, it's like, I'm there just for show, just to be pretty, right? I'm not actually approaching it. That's busted. You're much better stopping your graph there. It's still asymptotic, okay? All right. Are we finished?
I have a question.
Yes.
How do you know how deep you do the thing?
Do you mean like here or here?
Yeah.
Okay, good question. And which goes right into my next thing. There is one thing missing from this, or more specifically two. Namely, as we learned in logs, a point for scale, right? Because this at the moment is exactly the same graph as this, right? It will look exactly the same, or this, right? They're all the same. I've just put a vertical stretch on it, okay? So therefore, to tell the difference between these, I do need a point for scale, okay? What would you suggest as a point for scale?
1.
X equals 1 would work. So when I put in x equals 1 into here, I get y equals 1 plus 1 over 1, which is just 2, okay? So I know roughly where I am. Now, here's the tricky part though, okay? Can you see how this graph, it's coming down, it's decreasing, and then at a certain point, it turns around and it starts to increase. You see that? Okay? So we call this, because it's coming down and then it turns and goes up, we call that guy there, we call it a turning point, right? Because it's a point where the graph turns, okay? Some names are very, very common sense. They aren't all, but anyway, okay? Now, here's the thing though. To work out where it turns, there you need one of two things. You either need calculus, you need to be able to differentiate this thing, or you need to know what a discriminant is. For this particular graph, you can use the discriminant in quadratics to work out where it actually turns, okay? Now, we will learn all of those in time, but for now, you don't need to know, you're not expected to know either of those two things, so therefore, you're not expected to know where that actually is, okay? So you can call that 1, 2, and that's close enough, okay? Now, by the way, that implies, because it's an odd function, I have another point for scale now, don't I, which is? -1, -2, right down here.
But you wouldn't get a multiplier if that wasn't the exact score.
Not yet.
Okay.
Not yet. Okay? Because the time will come, and I'll even do it today, where you can work out where those points are, and you can work it out precisely. It's not hard. Okay? And once you know that, you will be expected to put it on accurately. Okay?